Alright, so one of the questions on the homework is if you're given a mass of impure yttrium carbonate and you're asked to find how much what the mass percent of the yttrium carbonate is, but you're given the equation Y2 CO3 3 plus HCl goes to Y Cl3 plus CO2 plus H2O, and then you're given the equation HCl plus NaOH, and that's going to go to water plus sodium chloride. Okay. At no point are we given a mass of yttrium carbonate. We're given volumes and molarities of hydrochloric acid and sodium hydroxide. Before we start dealing with that, let's make sure we balance this. Okay, so if we go through and balance, we should have 1 yttrium carbonate, 6 hydrochloric acids, 2 yttrium chlorides. That's going to give us 3 CO2s and 3 waters. Now, the math from here is going to be similar for your particular reaction, but you're going to have different values to put in. In this particular case, we were given 50.0 milliliters of HCl. And that was allowed to react in the reaction with the yttrium carbonate. The excess hydrochloric acid was neutralized in the second equation with sodium hydroxide. And that was 7.55 milliliters of a 0.104 molar NaOH solution. Okay. So this is our starting point right here. I know it seems really far away from all the stuff we've talked about, but we need to find out how much hydrochloric acid we have left. And once we find out how much hydrochloric acid we have left, we can put it into here to find the amount of yttrium carbonate. So to begin this, you can take the 7.55 milliliters of NaOH. Okay, convert that to liters per 1 liter. Then multiply by the molarity to get the moles of the NaOH. So 0.104 moles of NaOH per 1 liter NaOH. Then we use our equation up here, 1 mole of HCl to 1 mole of sodium hydroxide. So 1 mole HCl to 1 mole NaOH. You could stop here and solve for moles of HCl and then convert the 50 milliliters of HCl to moles. But I'm going to go a step further. I'm going to go to the milliliters of HCl. We know that the molarity of HCl in this particular case is 0.0965 molar. So it's moles of HCl per 1 liter. And when we multiply back to get to milliliters, multiply by 1,000 milliliters per 1 liter, this is going to tell us that we actually used up 8.14 milliliters of HCl in the neutralization process. So how much did we use in the first step? Well, we have to take the 50 milliliters of HCl and subtract 8.14 milliliters of HCl neutralized. To appropriate significant figures, that's going to be 41.9 milliliters HCl used in the yttrium carbonate reaction. Now we can go back and change this value here to 41.9 milliliters of HCl, and we want to convert this to grams of yttrium carbonate. So how are we going to do that? We're going to take the 41.9 milliliters and do similar calculations as what we did here with sodium hydroxide. Convert the liters, convert the moles of hydrochloric acid, then we're going to convert to moles of yttrium carbonate, multiply by the molar mass of yttrium carbonate, and end up with the mass of the product, or the yttrium carbonate that we used originally. So I'll set that up over here. 41.9 milliliters HCl. Divide by 1,000 milliliters per 1 liter HCl. Multiply by 0.0965 moles of HCl per 1 liter HCl. From our equation, we know it's 6 moles of HCl for every 1 mole of yttrium carbonate. Now we need to get the molar mass of yttrium carbonate. So the molar mass of yttrium carbonate is 357.8 grams per 1 mole of Y2CO3. When we plug this into our calculators, we end up getting the answer here as 0.241 grams of pure yttrium carbonate. Well, we're still not at the mass percent yet. In order to get to the mass percent, we're going to take the mass of the pure, so the 0.214 grams of pure yttrium carbonate, divide that by the mass of the impure, and from the equation it's given as 0.906 grams impure, and multiply by 100%. So in this particular case, it's going to be 26.6%. And that's the mass percent that you'll report.